An equation. Write an equation for line L. Line L is the red line. In point slope form and in slope intercept form. Okay, so they have a blue line and then they have a red line, and they want you to write the equation for the red line. Below the graph, it gives us some important information. It says that line L, the red line, is parallel to y equals negative 2x, which is the blue line. And you're asked to write the equation for the red line. And they've actually highlighted a point for you on the red line, line L. That line goes to the point 3, 4. So this brings up the topic of parallel. What do y'all know about slopes of parallel lines? They're the same. Y'all been taught that before? Okay. So if I'm trying to draw or to create or write the equation for the red line, then I need to know the slope of the red line. And since you said slopes of parallel lines are the same, then you can either count the slope for the blue line. You can pick 2 points on a graph and count rise over run, or you can realize that this equation is in slope intercept form already, which means solve for y, and the slope would be negative 2. So if I want to write the equation for the red line, then I have to use the exact same slope as the blue line if I want my equation to be parallel. So parallel lines have the same slope. And then I've got to pass through the point 3, 4. So we're just adding a little bit more information to some stuff that you did in section 2, 3. We're going to be adding parallel and perpendicular. So we're just using our knowledge of parallel. We know we have to have the same slope. So if the blue line has a slope of negative 2, the red line has to have a slope of negative 2. And then we just write our equation in point slope to start out with. And this will kind of feel like exactly what you did last night, except we're just adding in some information about parallel and perpendicular. And then you'll solve that for y. I'm going to let y'all solve it and just tell me what you get for y. Y equals negative 2x plus 10. Anybody disagree? Anybody have a question about where we got y equals negative 2x plus 10? Okay. While we're talking about parallel, we might as well talk about perpendicular. So in our notes, let's just go ahead and write this down. Let's write parallel lines have the same slope it's a pretty important statement. Parallel lines have the same slope, and perpendicular lines, this should have been a big P, sorry. Perpendicular lines do not have the same slope, okay? But we want something more specific than that. Perpendicular lines have opposite reciprocal slopes. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Most people don't have trouble with the same slope, because if I say what's the same number as negative 5, y'all say negative 5. If I say what's the same number as 1/2, you'll say 1/2. But let's discuss opposite reciprocal. So if I said 2/3, okay? If I said 2/3, what would be the opposite reciprocal to 2/3? Negative 3/2. So opposite means you have to change the sign. So if your slope is positive, you have to change it to negative. If your slope is negative, you have to change it to positive, and then you have to take the reciprocal, which means you have to flip it over. Okay? So anytime two lines have opposite reciprocal slopes, that means the two lines cross and form right angles. Okay? Anytime two lines have opposite reciprocal slopes, the two lines cross and they form right angles. Now the only other situation that you would have is if you had a zero slope. Okay? Because we can't really you can take the reciprocal of 0, but when you take the reciprocal of 0, you get 0 in the denominator. Are y'all with me? 0 is kind of funny because it's neither positive or negative. So when we're talking about a 0 slope, we can't take the opposite reciprocal of 0. You just need to know that 0 and undefined would be slopes that are perpendicular. Explain that to me, why a line that has a 0 slope would be perpendicular to a line that's undefined. Mary Frances.
Because a line with 0 slope is a horizontal line, and then a line that's undefined is vertical, so they would still make right.
Everybody agree that horizontal and vertical lines, if they cross, always form right angles, therefore they would always be perpendicular? So this would be your other situation that doesn't completely follow. You can't change the sign of 0. You can't make it an opposite because it's neither positive or negative. So you also have to consider the slope of 0 and undefined. All right, in the next set of directions, the directions are going to say, use the given conditions to write an equation for each line in slope-intercept form, and then point slope, and then slope-intercept. So this time they're going to give you some information that's not in a graph. We're on number 6. So in number 6, they're saying, write an equation of a line that passes through the ordered pair -2, -7, and is parallel to the line with the equation y equals -5x plus 4. So this time they're taking what was on the graph in example 2 and they're just putting it into a little sentence for your problem. So you're trying to write an equation that passes through the point -2, -7 and is parallel to the line that has the equation of y equals -5x plus 4. So key word here is parallel. So your brain goes parallel. That means same slope. Okay? And so you're going to look at this equation and you're going to determine what the slope is. And so we're thankful because this equation has already been solved for y, so we can just take the number in front of the x, and that slope would be -5. And if we want our line to be parallel to y equals -5x plus 4, then our slope needs to be -5. And once you find out what your slope is, you don't need y equals -5x plus 4 anymore. We just use that equation to find its parallel slope. So don't get caught up in that. Sometimes I just put an X over it once I've used it so I don't go back and look at that. Then I go to my information. I have a point and a slope. So we're going to do y plus 7 is equal to -5 times parentheses x minus a -2, which is a plus 2. Directions say I got to have an equation that's in point slope, and then I need one solved for y. So y'all tell me what we get when we solve that for y. Anybody disagree with that? I think y'all can solve for y, so we won't spend time in our notes solving for y unless you just have a specific question. All right. Everybody got 6? All right, moving right along. Number 10, same set of directions. Here's a point. We need to write an equation that goes through this ordered pair. Again, they're saying parallel. We'll get to perpendicular in a minute. And it's parallel to this equation. So the equations will start to get a little bit more complicated. The equations will start to get a little bit more complicated. So if you don't know what you're doing, some of you might say that the slope is 3. I've seen that many times. But why is the slope of 3x minus 2y minus 5 equals 0 not 3? So it's not in a form where I can just say the number in front of the x is the slope, because you're either going to have to solve for y or you're going to have to use a little shortcut for general form. Does anybody remember the shortcut for slope for general form? I think it was negative a over b. And a lot of people never remember that. I'm just going to put it there in case somebody might can remember that. A is in front of your x. B is in front of your y. So I'm just going to show you the shortcut. If you remember it, great. Most of you are probably just going to solve for y, which is the longer way. But if you understand it, that's all that matters. So if a is a positive 3 and the slope is negative a, then that'll be negative 3. This is just the shortcut over your b value, which is negative 2, and then that will reduce 2 negatives, make a positive. So the slope comes out to be 3/2 if you want to use the shortcut. Okay? Some of you won't remember negative a over b if your equation is in general form, so you'll have to solve it for y. Okay? If you solve it for y, that's what Abby was doing in her head, I think. Divide by 2, divide by 2. Sure enough, negative 3 divided by negative 2 is a positive 3/2. You really don't care about the y-intercept here. You're just trying to determine what the slope is, because parallel lines have the same slope. So ever how you want to determine the slope is not 3, the slope is 3/2. You can solve it for y if it's in general form, if the equation is in general form, or you can do the opposite of a over b. Now let's go back. That's kind of like my commercial. Let's go back to the regularly scheduled program, which is to write an equation that passes to the point negative 1, 3 that's parallel to 3x minus 2y minus 5 equals 0. So that means my slope needs to be exactly the same, right? So once you figure out what the slope is, you don't need all this stuff over here anymore. So just kind of forget that. Focus on the conditions that you have. We have a point and we have a slope. So we start to write our equation. That's going to be y minus 3 is equal to 3/2 times what? X plus 1, and this form is called point slope, and then they also wanted in slope intercept. So we're going to do this one together since it has a fraction. So we're going to distribute the slope. We're not going to pick up our calculators because we're better than that. If we have to pick them up, we will, but y'all pick them up when you don't need to pick them up. And then we're going to do 3/2 plus 3. So we need a common denominator. We can still do that in our head. The common denominator would be 2. And so we need to think about 3 as something over 2. What over 2 is equal to 3? 6. So then we'll do 3/2 plus 6/2, and that'll give us 9/2. If you want to use 4.5, you can. This will probably be the equation that you see. Alright, so all we're doing here is just taking what you did in section 2-3 and we're adding in parallel and perpendicular. Any questions about number 10? Alright, number 12. Write an equation that passes to the point 5, negative 1 that is perpendicular to, this is our first perpendicular one, x plus 7y minus 12 is equal to 0. So keyword here is perpendicular. So we know from our notes that perpendicular slopes are opposite reciprocals. So you have to go find the slope of x plus 7y minus 12 equals 0. So you could solve for y, but we do know there's a shortcut. If your equation is in general form, you could do the opposite of a divided by b. A is in front of your x term. So what number is in front of your x term? A positive 1, so the opposite of positive 1 would be negative 1. And what's in front of your y term? 7. See how easy that would be to find slope instead of actually doing the process of solving for y? If you can remember the opposite of a over b, it's a really quick way to find slope if your equation is in general form. Now, what is the perpendicular slope to negative 1, 7? Positive 7 over 1 or just positive 7? Perpendicular slopes are opposite reciprocals, which means you got to change the sign and you got to flip the slope over. All right, now we don't need all that stuff on the right anymore. We just start to write our equation, and so we get y plus 9 equals 7 times x minus 5, that would be endpoint slope, and then y'all are going to do a little work and tell me what you get when you put it in slope intercept. 7x what?
Minus 44.
Minus 44. You may disagree with that. All right, any questions about those types of problems? That'll be the first types of problems that you see in your homework tonight. All right. The directions are going to change, and I'm going to write them. You don't have to write them down, but the directions are going to say find the average rate of change. What do you love? Find the average rate of change of the function from x sub 1. Now this is really different. I don't know that you've ever done anything exactly like this, so I really want you to pay attention. Don't think, oh, this is something I've done before. I don't really need to listen. Find the average rate of change of the function, okay? And then it has from, and I left out that word, from x sub 1 to x sub 2. From. So you need to know, if I've not already said this, I'm going to say it now. Average rate of change is the same thing as slope. Average rate of change. When a line changes, it changes at an average rate of change. That rate of change is called the slope. So that means exactly the same thing. It could say find the slope of the function from x sub 1 to x sub 2. So we're looking at number 12. No, we're not. We already did 12. We're looking at number 14. So they're going to give you a function, and they're going to give you two x values. They're going to say find the average rate of change if x sub 1 is 0, 2, x sub 2 is 4. So that's going to be your given for information. They're going to have to give you a function, and they're going to have to give you an x sub 1 value, and they're going to have to give you an x sub 2 value. All right, and if we're finding average rate of change, which is really slope, we don't just need two x's, we need two y's that go with those two x's. So we can find some other y's because they gave us the function here. So if we take the first x sub 1, 0, and we plug it into our function, what is 6 times 0? 0. So when x is 0, x sub 1 is 0, y sub 1 would be 0. If you want to see some work for that, you can do 6 times 0, and that's how you got that 0. When x is 0, you have a function to plug in here. Remember? Function's like a function box. You plug it in, something else comes out. If you plug in a 0 for an x, you get a 0 out. What if you plug in a 4 for your x? That would be 6 times 4, which is 24. So when x is 4 in this function, the y is not 0 anymore. The y would be 24. Okay, so now you have two ordered pairs. What's the first ordered pair? 0, 0. What's the second order pair? 4, 24. And then it's just work the slope formula from there. Okay, they're going to give you two x's. You're going to find the two y's that match up with the two x's that they gave you. That gives you two nice little ordered pairs, and then you're just going to work the slope formula, which says second y minus first y over second x minus first x. That gives us 24 over 4, which simplifies to be 6. And somebody's going to say, did we not already know the slope was 6 in this particular function? Yes, because this function was linear, was it not? Is f of x equals 6x not a linear equation? Doesn't have an x squared, doesn't have a square root of x, doesn't have an absolute value of x. That would be a straight line, and it would have a consistent rate of change. But are all of them going to be linear? No, they're going to be starting to be curves, and at certain points the slope is different on a curve than at other two specific points, and then you just need to know how to do this process. Okay, let's look at one that's not linear. Number 18. Number 18, the function that they're going to give you is f of x equals the square root of x. So what's that graph look like? It's not a parabola, it's a shooting star. So a shooting star is not linear because it does not make a straight line. So it does not have a consistent rate of change, okay? Lots of graphs do not have consistent rates of change. So what they're wanting to know here is on this function, what is the rate of change from where x is 9 to where x is 16. So just to draw you a visual here, this is not a graphing situation, but just for you to understand, do y'all understand that the slope is different between those 2 points versus another set of points that you find? If you do not have a linear equation, the slope is not consistent. It changes based on the x's that you have. Okay? So there is no possible way I can just look at f of x equals the square root of x and tell the slope between the 2 points that have x's of 9 and 16. You have to work this one out. You necessarily didn't necessarily have to do 14, but I always want to show you something that's linear just to prove that it works. So what would y sub 1 be? Y sub 1 would be 3, and what would y sub 2 be? 4. Does everybody get where those numbers are coming from? Alright, that gives you 2 nice ordered pairs, 9, 3, and 16, 4. So just a visual here. You have a shooting star, you have 2 points, 9, 3, you don't have to graph this, and 16, 4, and we're really finding the slope of the line that would go between those 2 points. Y'all remember ever in geometry hearing the term secant line? A secant is a line that crosses through a graph and intersects at 2 points. So you're really finding the slope of the secant line that passes through the 2 points because curves don't really have a consistent rate of change. Alright, so work the slope formula. What's on the top? 4 minus 3. What's on the bottom? 16 minus 9. So that gives us 1 over 7. So the slope of the secant line that passes through the function, the square root function where x is 9 and x is 16, that secant line would actually have a slope of 1/7. Okay? And in higher mathematics, and once you get into a job that may use mathematics, sometimes, or a lot of times, data is not linear. And we have to look at curves and information that way. And sometimes we want to know, well, you know, what was the rate of change between these 2 items that were purchased in January based on June, and we could calculate things and use data from our graphs. Yes?
Will we have to graph these?
No. I'm trying to graph it just to give you a visual of what you're finding. Because sometimes you might have teachers who just say, oh, this is how you do it, do it this way, and whatever. But sometimes if you kind of know what you're doing, and then it's going to, knowing what they're asking you for will help you when you get to that next math class and you're not just have forgotten what you memorized and didn't understand it. All right, questions about 18? All right, changing directions here. When we get to number 22, the directions say write an equation in slope-intercept form of a linear function. So here they're just saying slope-intercept, no, just slope-intercept form. Yeah, number 22. All right, write an equation in slope-intercept form that passes through the point -5 and 6 and is perpendicular to, and then this information is just going to start to get more difficult. So we've kind of covered the concepts, and we've just got to have a little bit more brain power on something like this. All right, so this is our given. This is what's in my directions. I have to write an equation that passes through the point -5, 6 that is perpendicular to a line that has a x-intercept of 3 and a y-intercept of -9. So all linear equations have to have what? Slope, okay? So you're looking for perpendicular slope to the line that has those two intercepts. Anybody have any idea how we're going to find the slope? All right. Abby says we could write these intercepts as ordered pairs. Can anybody in here just visualize the graph and count rise over run in your head? No? I know there are some people that can. You have a y-intercept that's down what? 9. And you would rise 9 and run to the right 3. Can y'all see that in your head? Sometimes when they give us intercepts, we actually can see those points because they're on the axis. So the rise would be 9 and the run would be 3. If you could do that, then you could calculate the slope that way. So that'd be 9 over 3, and that would simplify to be 3. If you're not comfortable with that, then you're going to do the slope formula, which says negative 9 minus 0 over 0 minus 3. That gives you negative 9 over negative 3, which sure enough simplifies out to be 3. If you can visualize the graph, you can count rise and run. You can work the slope formula. There's multiple ways to find the slope, but now you have to find the perpendicular slope to positive 3. Negative 1/3. If we're not careful, we'll use the same slope every single time just because we're in a hurry or maybe we haven't read the directions. But perpendicular slopes are opposite reciprocals. So once you find your slope, you don't need this stuff anymore. Okay? Now, I'm not going to bore you with plugging all this in. We know how to plug it in. I'm just going to do squiggle, squiggle, squiggle. And they're just wanting slope intercept here, and we would end up with negative 1/3 x plus 13/3. You'd have to deal with some fractions there, but you can do that. All right, we're just really practicing how you would set these up based on the information that you're given. All right, the rest of what we're going to look at are just some random word problems because we're covering this whole section in one day. Everybody got 22? All right. So 26 has a bar graph. Let me see if I can take a picture of this real quick. All right, so 26 has a bar graph, and it says in 2000, 23% of Americans regularly use online news for getting news, and this has increased at an average rate of approximately 1.3% per year since then. The directions say find a linear function in slope-intercept form that models the given description. Each function should model the percentage of Americans, P of x, so they want you to use function notation. So instead of being y equals, they want you to use P of x, who regularly use the news outlet X years after 2000. So I'm going to read this again. In 2000, 23% of Americans regularly used online news. That's the beginning amount, okay? Your beginning amount is always your y-intercept. And we're not going to use 0.23 because we're not taking 23% of anything. It's just saying in the year 2000, the percentage that was actually using the online service to get their news was 23%. So we're starting at 23%. All right, and then this amount is increasing at an average rate of 1.3%. So that's our slope. Our average rate is 1.3 times each year. So you didn't even use the bar graph on that one. I took the picture for absolutely no reason. So they're going to give you enough information in your problem that the beginning amount is always your y-intercept, and then they're going to talk to you about rate of change, or a rate is increasing. That means your slope is positive. Or your rate is decreasing. That means your slope is Negative. The beginning amount is always the what?
Y.
The y-intercept. All right. On number 28, they're changing graphs. It says find the average rate of change rounded to the nearest whole number from 2001 to 2006. So instead of doing the graph for this one, I'm just going to, there's a graph, and you'll actually find two ordered pairs. Okay? So there is a graph. You'll go look at your graph, and they're asking you to write an equation from the year 2001. So I'm getting this information from my graph. If I go over to 2001, the y value is 1,273. I'm just looking at my graph to get that ordered pair. And then 2006, using my graph again, go up to the y value that is 612. Or down to the y value, excuse me. So you'll just use your graph. Okay, you're going to use the graph to find the two ordered pairs. That's not going to be the hard part. And then it says find the average rate of change. Okay, what's another word for average rate of change? Slope, rounded to the nearest whole number from 2001 to 2006. And then it says describe what this means. So this will be a word problem that won't be really, really hard. It's just an application problem. They want you to look at the graph. So we'll find the slope. That's going to be 612 minus 1,273 over 2006 minus 2001. I've got this worked out for you. That's negative 661 divided by 5, which reduces to be negative 132. So that's the rate of change of those two ordered pairs that you actually just looked at your graph and got. I have to tell you a little bit about the graph. It says number of active duty service members discharged from the military. And then it's got the years. And then it's got the values on the y-axis. And they're just wanting to know, they're wanting you to know that this number is, if it's negative, then between these 2 years, is it a decrease or is it an increase? It's a decrease. And then you would just use information that was actually on your graph. Right, you would kind of explain that. Let's see what else we got here. All right, number 30 is going to give you this horrible looking equation. You don't have to come up with this equation. They're giving it to you. It's definitely not linear. And I need somebody to tell me why it's not linear. Why is this not a linear equation? Yeah, it's got more than one x. It's got an x squared. It's got an x cubed. And a linear equation just has an x to the 1. It never has anything higher than an x to the 1. So this is probably like a roller coaster graph because it has an x cubed and an x squared. The A part says find the slope of the secant line rounded to the nearest whole number from x sub 1 is equal to 7 to x sub 2 is equal to 12. Find the rate of change from this equation if they give you these two x values. So this is where you're going to pick up your handy dandy calculator. And using your calculator, you're going to put in a 7 with parentheses. And you're going to tell me when x is 7, what your f of x comes out to be or what your y comes out to be. Pretty big number. Okay. 1067.3. And then if x is 12, 585.8. Is there anybody that doesn't know how to plug part of that into your calculator? Does anybody know how to get to the third power? You use the upside down V. That's the power key. Everybody good with that? All right, so this is just a little bit more complicated. We did an average rate of change earlier in our notes, but these numbers are a little bit bigger, but we have two order pairs, right? So then we're going to take the second y, which is the 585.8, subtract the first y, divide that by the second x. You can tell already that the slope is going to be negative because the y values are getting smaller. That's one thing that some of y'all described in your slope-intercept video is you said as x's get larger, y's get smaller. That means the slope is negative, and we'll figure that out once we work this out. So I ended up with a negative 481.5 over 5, and then I think it told us that we could round to the nearest whole number, negative 96. So that's the A part. That's the A part. Find the slope of the secant line. A secant line is just a line that crosses another graph at 2 points. Find the slope of the secant line between x sub 1 is 7 and x sub 2 is 12. D says, does the slope from part B, we can't do the B part because we didn't do number 49, so let's just omit the B part. All right, number 32 is just going to ask you some information, just making sure that you understand it. 32 says if two lines are perpendicular, describe the relationship between their slopes. Number 32, if two lines are perpendicular, describe the relationship between their slopes. Their slopes, let's be a little bit more. Let's say perpendicular slopes are what? Opposite reciprocals. Perpendicular slopes are opposite reciprocals. Again, the directions say if two lines are perpendicular, describe the relationship between their slopes. We would say perpendicular slopes are opposite reciprocals. All right, number 34. A formula in the form of y equals mx plus b models the average retail price y of a new car x years after the year 2000. Would you expect m to be positive, negative, or 0, and explain your answer? All right, so I'll say that again. Y equals mx plus b models the price of a new car x years after 2000. Okay, so this b would be the beginning amount. So let's say you drove a brand new car off the lot and it was $35,000. Just to give you I'm making this up just for you to see a little bit more of what they're talking about. So your y-intercept is always your beginning amount. Once you drive that car off the lot and you drive it for a whole year, what happens to its value? It goes down. So would you expect your slope to be positive in this situation, or would you expect your slope to be negative? It would be a negative rate of change because as each year passes, the value of your car is going to go down. So they're asking you about what would you think the slope would be in this situation, and we know it's going to be negative, and we would say something like value decreases over time. Value decreases over time. Last one, 36 says, what is the average rate of change? What is average rate of change? Slope. Just getting you to understand that average rate of change and slope mean the same thing. Average rate of change and slope.